All right. Well, thank you for everybody who is attending today. This meetup session will focus on layered networking or automating layered networks. So we're gonna use MPLS layer 3 VPNs as a target for our automation, but this discussion easily could be uh, you know positioned for other types of topologies and other architectures. Really anything that has multiple layers. So like if you look at an EVPN, VXLAN would be a good example as well. Pretty much anything from the perspective of like an underlay and an overlay. And then obviously to build that type of architecture and the represented tiers of that architecture, we're not going to build it all at once. So from like a router perspective, normally, we're focused on the underlay first, and then once we have that infrastructure, then we can start transposing like tenant infrastructure or tenant connectivity and constructs on top of that, or whatever the virtualization is. So in this case, it's VPNs on top of MPLS. So it's not so much MPLS as a technology with layer 3 VPNs. It's more just an example in how we can approach that type of infrastructure. So we'll go through a couple of things first in some slides to set a backdrop for the demo and to level set on a few of the main tenets that we need to understand, to be able to use these techniques and implement them in our Ansible automation. So some of the considerations when automating layered networks is really, can you take advantage of data models, right? So in terms of data models, this is our abstraction and representation of the native CLI that we would typically configure the devices using those constructs. But with data models, then we can take advantage of being able to offer abstraction and to make said infrastructure programmable. So a lot of times that can be done to some extent using device automation, but normally we're talking to multiple devices, and in some case it's very diverse. So in a heterogeneous type of environment where we may have routers, switches, firewalls, single source of truth from like IPAM or other like ITSM types of configuration management types of components as well, then there's a lot of integration points. So that really lends itself better to orchestration. So in the demo, it's deployed using the Ansible automation platform, or more specifically, the automation controller, which some of you may be more familiar with the term Tower. But as Tower has evolved into a platform, the Ansible automation platform, the automation controller really takes the place of what Tower used to do in terms of managing the automation and giving you the guardrails and other capabilities that are really required in order to be able to provide automation into production networks and at scale. So the third bullet here is just to call out multi-vendor. So that kind of is a linkage back to the data modeling, because when we look at data models and some of the other like standard-based data models like Yang, most of them are meant to be multi-vendor. So you're subscribing, to a particular standard. And then, of course, there's always those one-offs in terms of proprietary features from a particular vendor. So if you look at like EIGRP routing or something like that that's very Cisco specific, then that would be handled with their native model, right? Because that's more proprietary. But IATF and ITU, like from OpenConfig, as another example, those are meant to be broader in scope and to encompass multiple vendors. Well, with Ansible, we have a way of providing multi-vendor, but it's a bit more simplified. So we'll drill down into that. We'll drill into that a bit, just to give you again more of a backdrop before we go into the demo, and to speak to some of the value that Ansible brings for those types of environments. So this one here, ancient automation, or not really ancient, but definitely more difficult around the Yang data models. So if you've worked with Yang, and some of you may be very familiar with it and have that as your preference. For me, I have, so I do have some opinion in that regard. But for me, like personally, I had a real challenge learning not just Yang, but like the whole set of skill sets that are needed. So I've always thought of it as, kind of a high barrier to entry, because in terms of skill sets, there's a lot to take on before you can actually start to move forward and automate using these techniques. So if we look at the Yang models, there's more than one, right? So you need to be familiar again with the native ones, which are more proprietary in terms of the vendor. OpenConfig is newer and more popular and available on most the modern platforms. And then you'll see IETF out there, and all of them have some of the common challenges is being able to parse through them and create a path to the object that you want to configure, or to point to like an operational object for the purposes of requesting operational data back from the device, or leveraging streaming telemetry with gRPC or GMNI. So there's like a whole skill set around that, and that requires you to learn Python to some extent as well, because most of the Yang-based automation tools to do to build like your own custom function packs or service packs, or depending on what the solution is. Normally that does allude to Python skill sets, and things like the NC client allows you to interact with netconf. And there's also RESTconf. So sometimes nuances and different challenges between those two, more around the lifecycle management. So like if you look at RESTconf as an example in networking, that's a tough one to support sometimes, because that would also allude to the need to manage multiple devices that have certificates. So instead of managing SSH, which is fairly straightforward from a network infrastructure perspective, it's just more operational challenges, and in this case around security, and being able to provide all of the wrapper of these peripheral skill sets around this. And then the last one down here, like XML. So some of the solutions require XML to create templates, and I'm not I'm able to read XML, and it's okay and everything, but it's not my preference either, because it's just, for me, it's just hard to look at, right? So you have those open and closed tags. So when you create a dictionary, your values are kind of in between those tags. So it's just a little bit harder for a human to parse through that stuff. So normally we would use XPath. And XPath is a way to point directly to one of those elements that you're either configuring, or in the case of like streaming telemetry, it's very valuable, because then you can point to an object or an operational state, and then be able to have that available as part of an event that you would send through that trigger outbound, like dial out or dial in, depending on how your streaming telemetry is set up. So that's all good stuff, and it's very useful, but there's easier ways to approach the same problem, and Ansible does support all of this stuff, right? So you can use modules that give you access to these Yang models and netconf and the like, right? But what I want to talk about today is using an alternative through the resource or the network resource modules. So with the network resource modules, if you're familiar with those, and if you've been following the more current implementation of Ansible, you'll notice that we have certified collections, and we also have the, from an open source perspective, we have the community. So the community is the Ansible Galaxy, and then if you're a customer of Red Hat, then you would have access to the console, which would give you access to our automation hub, where you can download the certified collections. And in those collections, you'll notice that all of the network vendors that are participating, and that includes vendors that have routers and switches, but also firewalls, and then similar to that, load balancers, and many of the devices that we can either access through SSH, or if they have a REST API, depending on if it's not a router or a switch, it might not be RESTconf, but it might be some flavor of a REST API. Those are starting to build their resource modules, and the value of the resource modules is that it's very it's very scoped to a particular configuration. So in the sense that it's only focusing on like one subset of your overall configuration in the device. So if we're configuring, as an example, like VLANs or OSPF routing or BGP routing or access control list or configuring interfaces, all of those have a resource module. And one of the things that makes it very useful for those who might not have the command line expertise, or perhaps like you don't have the command line expertise across all of the vendors in your environment. Maybe you're stronger on Arista and not so strong on Juniper, or more strong on Cisco versus Arista, right? Then you can normalize a lot of this, because instead of needing to know very specifically the syntax of the command lines, then you can take advantage of the resource modules that work with structured data. So by default, it will allow you, and depending on what state you configure, when you're either making a configuration or if you're requesting like operational data in terms of like gathering information, then that is through JSON, right? So we can take that and we can clean it up and use filters, right? So we can have JSON, YAML, XML if that's your preference, right? It really doesn't matter, but it gives us these options to work directly with the structured data. So this builds a model, because now that we have configurations that we can build one at a time and leverage that structured data, we can go to like an existing brownfield environment and we can ingest those configurations. And then from that, we can automate devices that weren't previously automated, or for devices that are different vendors. Because we're working with structured data, we can pull out a configuration and then we can manipulate it, because oftentimes there still might be some nuances even within the structured data, but we'll be able to see basically what that model looks like, and we can easily manipulate that data and use it to like migrate like from one vendor to another, or one like an older platform to a newer platform, or a different OS as you make these changes. So it makes it very malleable and easy to work with. So the resource modules, from my perspective, in my opinion, is to suggest that you try to use those first, because they're very easy to use. And once you become more familiar with them, you can go a step further. And we've started to package resource modules in very specific roles. And if you're not familiar with a role is like a repurposable, very specific, like purpose-built playbook. And it's meant to be generic in the sense that you can run, variabilize it, and then use it and call it from other playbooks. So if you create your own custom roles, you can use them in your environment and share them, or you can use the roles that are often provided in the collections that the vendors provide, along with their other playbook examples. And more recently, we have what we call validated content. So with the validated content, you can think of it as a very prescriptive role that manages other roles that are already available in these collections, but it's to do something broader. So instead of just like building VLANs or OSPF or BGP, maybe it's to build like an entire, EVPN VXLAN, or something like an SD-WAN configuration, where the vendors are working with us to certify and go through like rigor for these validated contents, so that it is more of a blueprint, if you will, or more like a traditional validated design from these vendors would typically give you the baseline configuration, or that recommended prescriptive configuration, like what you would do command line wise or through the GUI. But this would be the same thing. It's just like, how would it look in Ansible? And instead of you having to build everything from scratch, like in this case, this L3VPN MPLS, then most of it would be available to you out of the box. And then you're obviously going to want to tweak it and change it and modify it some for your own purposes, but it's going to save you a lot of time. And again, it's meant to work across vendors and to be very flexible in terms of manipulating the data, which is a big advantage there. So another aspect of the resource modules that I like is that it's so easy to provide what we call a source of truth, and to manage configuration drift. And the reason for that is these modules, these resource modules, have built-in diffs. So on the next slide, I think I have a depiction of that, but basically it takes a before snapshot. It will show you the actual command line configurations that it will send. So even though it's front-ending you with a playbook that you're using from that module, the parameters that you can define, right? And then on the back end in the module, which is typically the Python scripts, right? Because this is, mostly networking stuff, then what you'll see is that it turns it into the command lines, the native command lines, and it sends those over the line. So that's the serialized data that's sent directly to the devices. So by doing it this way and using resource modules, then it's already kind of ready to go out of the box. And what you can do is you can make that diff also comparable, not just to like the running config, versus your configuration that you pulled in, for your variables, but also you could point it to external sources of truth. So you could, look at other things like info blocks, device 42, netbox, just any of those systems that may have even a database, or your single source of truth may be across, multiple solutions, depending on how many domains you're kind of stitching together. Maybe it's like a DNA center for part of it. So really any of those other sources of truth that we have a module and a collection for, you can call those REST APIs through the module and pull in data and then use that for comparison purposes. The drift part of it is when somebody goes out of band and perhaps they make a change to the device that is out of, it's not in compliance with your policy. So you may want to overwrite that change. So you would be able to detect that change and then make that decision on if you want to overwrite, or perhaps somebody went out of band and troubleshot something, and now that solution needs to be incorporated on the front end in how you configure these devices. So you can ingest that change and make that a part of your front end configurations. So cool stuff here. And you'll see in future sessions, we'll touch on this over and over again in different scenarios, but it's very helpful. And this is just to call out the diff component of it. So it does have a before, and it does have an after, and it shows you the commands that it will send to the device. Now there is a caveat here. You can use check mode, and if you run a resource module in check mode, then it will show you the commands that it would need to send to make that configuration change. But you'll notice the after will still look like the before because it doesn't implement those changes. It just shows you what would change, even though you see changed when you see the standard output of the running playbook, but it's not going to change it. And if you go to the device to check it, you'll see that there's no change made. But it does provide you a way of doing like a compliance check up front. And then perhaps you have in a workflow, you might have an approval step where you actually wait, and there's a downtime later where you actually run that playbook again in run mode and actually, at that point, implement the change on the device and change its configuration. So that one there is used a lot, in compliance checks. So one other thing before we jump into the demo is I'm using resource modules. I'm also using validations. So that's how I check operational state, through validations. So if you're not familiar with this particular module, what it is, it's the Ansible utils.validate module in here. And what we can do with it is we can couple it together with parsers. Sometimes you don't need a parser because the data that we're gleaning from the device, maybe we use like network facts. Those come back as structured data already. Some of the operating systems already support JSON natively when you're like pulling in like the equivalent of show commands. But sometimes, like in iOS XE as an example, there's areas that still need to be parsed. So sometimes we'll couple together validations with parsing on the front end. So there's several different parsers. In this example, we're using PyATS. Right, so you can use that. You can use the network to code. You can use the text FSM. It really doesn't matter as long as the parser is converting that unstructured output into structured data. Then you can use it with a validation. So I don't have like the utils part of it in this example. I thought I did have that part of the screenshot, but you'll see that in the demo. So effectively, what I'm going to do is I can do like a show IP OSPF neighbors or show BGP. Neighbors, or really any of the show commands to validate that our network is actually working. And then using that module, it's either pass or fail. So if my criteria is like established, like for BGP, and if it sees it idle, then obviously it fails. So you do want to incorporate a little bit of a pause, right, or retries, because sometimes your connections don't come up immediately, right? So when you converge these neighbors, it does take a little bit of time. So I incorporate a little bit of padding in my playbook, so that way we have enough time for it to cycle through and to become, an established BGP peer, as an example. And then the last thing here is super important, because what you'll notice is like always check resource modules first. And then what can you do if you don't have a resource module? So in the event of not having a resource module, then my workaround is typically to use Jinja 2 templating, because you can implement them using the config module, and it gives you like a great way of providing the one-off configurations that are not available. So some of the reasons why they may not be available is most of the resource modules are around like those common configurations that work across multiple vendors. But that's not like the end game, right? So like really the goal is for these devices to have like full coverage of like what you can build from the command line and have those available as resource modules. But the reality is that some vendors are further along and it's going to take time. So you will run into cases where when you're trying to convert your manual configurations into automation, if there's not an existing resource module, then I would suggest using Jinja 2 templates, because that would cover anything. But the difference is that with the resource modules, it's parameterized and it's abstracted, so it's really easy for you. But with the Jinja 2 templates, once you learn how to create the template, it's pretty straightforward, because you're just creating placeholders for variables. If you want to get fancier, you can iterate through loops, right? And you can have conditions, just like you can with the playbook. But effectively, the hard part is you need to have the exact syntax. So whatever the command line is for that device, you need to make sure that that it's exact. Otherwise, you will have an error when you try to run these templates. So more or less, you just need to copy command line configurations that you already have, and just make sure that when you create your variables, you're not causing any issues there. So I think there might be a question. Let me pop over here. I think I heard something. Oh, it's an admit. Let me admit this person. Sorry about that. Yeah, if you were waiting, sorry about that. Okay, so we got it in the chat room here. Okay, it's not a question, it's a comment. Okay, cool. Yeah, I just want to make sure I wasn't missing anybody's questions. Let me pop back in here. So resource modules to lead with, Jinja 2 templates to fall back on. Another option you do have, but I really don't prefer it, is in the config modules, you also have lines. So the lines parameter, you can actually include like line by line configurations, or if it's embedded, like nested, you can use a parent parameter and then have the lines underneath. You can also do it before, like if you need to do like the equivalent of like a no to like remove a configuration before you add your new configuration, you can use those. And again, they require you to know the command lines as well. But the problem with them is that you have to iterate each one of those lines. So if you're running this against multiple devices, or if you have several lines of config in your playbook, it's going to take a lot longer to implement it that way, as opposed to a Jinja 2 template. You'll notice that happens very quickly. Just like resource modules, they're very fast. So from a performance viewpoint, I would definitely look at a Jinja 2 template and only use like the lines for like very small config changes, right? Because there's no sense in creating like a very complicated template if you don't need to, if it's just a couple of lines. But if you start getting into like multiple lines, you'll notice right away a difference. You can easily do a comparison over so many devices and see that you're going to get better performance using Jinja 2 or using the resource modules. So in this demo, what we're going to build first is our MPLS environment that has a dependency on BGP. So we're going to create BGP under the hood. And then that is, once that's there, it's only 2 sites, right? So like that configuration is all covered under resource modules, the things we would build here. So this one is pretty straightforward, and it would fall into that bucket, for multi-vendor and being very simple. When we get into the layer 3 VPN, when we start to create those configurations that map the VPN number to the route descriptor and like this type of stuff here, then those are not covered in resource modules. So if we look at like ILS XR and ILS XC, that's an area where we would need to create our templates. So you'll see that. I'll show you what my templates look like. They're very simple templates, but those are templates versus using only resource modules. So I kind of have like, the underlay part of it is heavy on the resource modules, and the overlay is leveraging templates to build those. And again, I'm not doing anything fancy in my templates. It's pretty straightforward. It's just some variable placeholders because our VPN number might not be customer 100. It might be customer 200. So if I want to provide like options there, I also need to provide options for different IP addresses and other constructs that we'll need to be able to build like more than one tenant, in the same environment. So the templates, fill the bill there. So let me pause for a second to see if there's any questions, and if not, we can go ahead and kick off this demo and do a double click into the details. So is everybody okay? I think you can unmute yourself if you need to, so feel free if you do have a question. Okay, so it sounds like we can go ahead and move forward. So this is the automation controller. If you're not familiar with the controller, normally we would start here at the dashboard. And you can see that there's not a whole lot of information in this dashboard, but the intent here is to collect information over time. So that way we have, historical information on how many of our jobs failed and those types of things. And we can double click into that information, particularly around our jobs. So every time we run a playbook, that is mapped to a job number. And that becomes like historical data that we can go back in time, and we can actually rerun that playbook from a previous job, and it'll still have like the other information that was collected, like artifacts and variables and stuff from back when we first ran the playbook and mapped it to that job. So this one doesn't have a lot of data because I'm logged in as this MPLS user. And the reason I did that is because this system has roles-based access. So when I log in with this user, I'm not an admin of the entire system. So one of the things you'll notice right away is when I look at templates, I only see the ones for the Layer 3 VPN and MPLS. I don't see any of my ACI stuff or any of my, other demos that I have, which I do have several, demos, and this is, my personal controller. I have tons of stuff in there. So to keep it cleaner and easier to look at, then I'll use roles-based access. But in practice, you would use it also to prevent folks from these playbooks that don't need to have access to them, or to limit what level of access they have to these particular playbooks. So a job template maps to a playbook. So like if I click into one of these, you can see that this one maps to this playbook called core-bgp.yaml. If I wanted to give somebody, edit access, I would give them admin privileges to this particular job template, which I have here, right? Because I can actually go in and edit parameters. But I can also launch it. Maybe I only give you access to launch the playbook, but you can't change it. So, there's various levels of access, and it's not just job templates. I'll kind of quickly walk through some of the other components that you can configure and limit access to using the roles-based access as we go through. So, how do we get to the playbook? Where is the playbook, right? So the playbook and access to it is defined in the project. So I have this project called BGP-base-MPLS. And when I go into here, you can see that I'm pointing to a GitLab repository. So after this is over, I always put these recordings out on YouTube, and I go back to the Meetup channel, and I'll put the links in there. So I'll give you the link to this repo, and it'll also provide you a topology if you want to rebuild this thing in Cisco Modeling Labs. I'll put that in there as well. So this is where the code actually is, but this is the recommended way of doing this so we can work as a team and we can manage like different stages in our Git repository. So like we might have like a development stage, a staging stage, a production stage. And then that way we can, manage our playbooks, our templates, our configuration files with the variables defined. All that stuff can be managed as code or infrastructure as code. But we could work locally. So what happens here is that we clone down this repository, and it's actually stored locally. But you don't see that here directly. You see the playbook directory, but you don't see like the full path because I'm not an admin here. But normally that's in the vars lib AWX projects folder, and I would have to have admin access to show you like what else is in there. But normally the way I do it is I'm always working from the repository, and then we pull down those files locally, but we have to sync them before we run them. So we'll pull down the latest copy of whatever's in the repo before we actually run the playbook in case somebody made a change. And then that way, we're capturing the most current file or the committed file. Oops, here we are. All right, so that's the project. Another requirement before we run a playbook is having an inventory. So here's my inventory, and just like any inventory, I have groups. So here I have a group called core and a group called dist. And if you click, I can double click into here, and I can see that I have group variables that map to, in this case, it's the core group. So I'm using iOS XR as the OS, and I'm using network underscore CLI. So this makes sense to any of those routers in that group or iOS XR routers. But when I go into the other group for distribution, I'm using iOS XE, or just iOS in the way that we define it in Ansible. So that's what we have here. This was just here because I was running this in a CI/CD pipeline, and if I were to make a change, it was going to trigger the workflow to start. So it's just, that was like a different example. We're going to use a self-service survey to kick this off so that we can present input options for the end user so that they don't even need to interact with any of this stuff. They can just launch the workflow, and they might not even launch it directly from the automation controller. It may be launched because they've opened up a ticket in ServiceNow, and that triggers the workflow, or we launch it, from other mechanisms or other software using the REST API. Because everything that we do in the controller and the GUI, we can also leverage a collection for the controller and do everything as code. So there's really 3 different ways, like the raw REST API calls, the collection for the controller, or we can manage it directly from inside the GUI like we are right now. So just to show you like the host here, if I go at the host level, you can see that I have host level configurations that only really mean something specific to the host, or for that particular host, like these IP addresses and things like that. So I'm going to go ahead and show you one more thing in the inventory because I believe I set it up this way. Sources. Yeah, so I sourced my inventory from the project. So if you recall, the project pulls down the code, all the files from the repository. One of those is the inventory. So what I'm doing is I'm pulling in the inventory from my GitLab repo. And if that inventory were to change, then I would update that here in the AAP. So like if we added like a new device or removed the device, then that would be updated when we sync the inventory to the repository. So there's a lot to that. We don't really have time. I'll probably do a session just on like dynamic inventories is like a really cool topic where you can use just about anything that maintains like the IP addresses of your devices, and you can use that as the source of your inventory. And as that changes, and it could change dynamically, then that would update your inventory in the AAP controller. So that way you're always able to connect to whatever the latest IP is for those devices, which is something that happens in public cloud a lot too, right? If we're not using EIPs like Elastic IPs and Amazon, those could change when you reboot, so then we would update, those there. So there's a lot of examples of, dynamic inventories adding value. But for most of the stuff, you can use static inventories and it works fine unless it's going to change, as we talked about. So we'll go into templates. And I know I said a lot there, but it was just kind of leading up to this. So job templates map to playbooks. Workflows allow us to stitch together multiple job templates. Or we can go a step further, and we could even use a workflow that manages multiple workflows. So there's a lot of complexity that you can build in orchestration using workflows. So if we look here, and I'll just show you before we start here, I ran some jobs earlier. I ran this cleanup job. So what I wanted to do was remove the previous configuration from those devices. So the devices themselves are over here in this CML. So this CML is running in Cisco's dcloud. And I was able to reserve it. You could also use the sandbox in DevNet, but the one in DevNet you can't use as long. So this one you can actually reserve longer. So if you have like an account that gives you access to dcloud from Cisco, you can run these for like a whole week. So this one here, when you click on it, you can see like the connections between the distribution to the core. And then I have this out-of-band connectivity through a VPN over here. So through the VPN, I can actually touch these devices directly. and my AAP controller is running on my laptop. So it's using this tunnel, and then I'm able to configure these devices. And this is something like if you're in the study group, which happens, on the second half of this, we'll switch over to the study group. I use a CML environment in DevNet for that as well, so that we have devices that we can manipulate. And it's free and it's easy to spin it up. And once you start using it, it's not too much of a hassle at all. So these are running here. If we want to go into them directly, we can go in the console and we can see, configurations and the like. Right, so my interfaces and stuff are in here. And if we need to validate something, if it doesn't work, we can go back in here and we can look. But right now, there's not a whole lot in here. We just have some OSPF, but no BGP. So this is just kind of like the baseline initial configuration. And that's what the cleanup workflow did. It removed all the configurations. So having said that, we're at a point where we can go into the workflow and kick it off. So I want to be in this one here. We want to build the VPN. So I'll click on here. This is a workflow. So what will happen first is we're going to build that core BGP that was needed for the underlay component, and do a bit of MPLS in here, so that we can start to work on the layer 3 VPN part of it. But what I'm doing here is a validate step. So I mentioned we can do these validations like pre-post checks to validate if something is working or not working. So it's kind of like PyATS with the triggers, right? So it's the same kind of thing. We want to look at like our neighbor adjacencies and that kind of stuff. So Ansible has a way of doing that, and we just use JSON data or YAML, and we can point directly to whatever that that object is or that element is. So whether it's an on or an off or a true or a false, or it's some type of timer, or like how many times something happens, like if a CPU starts to degrade or something like that, we can watch those and create conditions for pass or fail, right? So in this one here, if this validate were to fail, you can see like I have a green line. You can't really see because the green line is really gone from the core BGP to the validate here. But if it were to fail the config, it's set to roll back the config. So just like I had that workflow that was rolling back configs, this would be the one that would roll back my core BGP. If it passes, I move on to this BGP validate to make sure that I have some of my MPLS settings at this point. It'll check and make sure that we have all of our neighbor relationships and everything's good here. And if everything's good, we move into further configuration. So here is the point where we will apply like the customer's VPN number and their IP addressing and those specific elements that are for their overlay VPN connection that we're going to provide from CE to CE. Now, if those fail, then we have rollbacks, very specific rollbacks depending on which one fails. And then if they pass, we move forward to a validation step. So here we're validating again, right? So you'll see that we have checks in place here. And if everything's good, we move on to configuring IPSLA. And the IPSLA will be different depending on if we configure VLAN or VPN 100 or VPN 200. So I didn't put like a bunch of different options, but like we could pick one or the other, and it will choose the IP address based off of which one it is to check like end-to-end connectivity from like the CE side to the other CE side. And then if everything works, then the IPSLA will also be checked as operational state. And if it works, then we will succeed and we'll move through this whole thing. So I'll go ahead and kick this off. And you can see here that I only have these 2 sites. And I just put this in here as an example because maybe like in a real infrastructure, we're going to have several endpoints, right, or sites that we can select. So here we just have 2. So there's nothing to change here. And then here, just to have different options, I have 100 or 200. So when I build this, I have to also state like which one I want to remove, right? So depending on whichever one I do. And when we go into the variables, you'll see the only difference between them is like different IPs and stuff like that. So once we select whatever the input options are from the survey, then those become variables, right? So here we can see we have site A and site B. It's just a list. And then VPN 100. So we will populate that variable when needed. And then I'll go ahead and launch it. And this is a notification. So this is coming into Slack, but it could be any chat op tool that has an API. But the important part here is that it maps to my jobs. And it gives me a cross-link. So when I click on these, it takes me like directly back into the AAP. So you can see that brought up like a new tab over here. But this would be important, like if we had a team of folks, right? And we want to send them notifications, not just for the whole workflow, but each one of these job templates. And they would have more information to be able to see if it passes or fails. And if it fails, then they might need to, intervene at some point to do some troubleshooting. So we might roll back, and then we need to see, okay, why did it break, and then try it again. So here we finished this particular job template. So I can look at that output. So we can see as we go through this, we're loading a role for BGP. And I'll take you into some of these files too as this is running to give you an idea of what's in here. But what we do see is that we have some configs that are changing, right? So configuring the loopback for BGP. OSPF was already in there, so notice how it's green. So anything that changes, and depending on your display, it might be brownish or orange or yellow, but this indicates a change. Green is indicative of, OKs, which means it didn't change because it's idempotent. So anything that's already existing as a configuration, if we're set to merge that config, if it doesn't need to change, it's not going to change it. It'll just move on to the next task and then make changes there. So if you want to see like something that did change, you can click and go into the JSON, and you can look at the resource module information. So you can see before and after information. So these are the commands that were needed to make the configuration based off of our variable file. But we didn't have to provide these. These are provided because of the way that the resource module works with the command lines on the back end. But it did look at it before, and there was, in this case, just an AS number in here, and then we provided additional information, which is all this other configuration. And see how this is just JSON, right? Because this is all structured data. And if you go to the documentation for like the BGP resource modules and the like, it shows you what that data structure is. Sometimes it's a dictionary, sometimes it's a list of elements, sometimes it's a string, sometimes it's a boolean, just a true false condition. It'll tell you what format it needs to be in, and then you can populate those parameters. So these are just all parameters. I set, parameters that were needed, but you can see there's a bunch of parameters in that module that we didn't need, so they're just null, right? But these are things that we could have changed, but we didn't. So down here in the neighbors, the same thing. So just the neighbor information, and then a bunch of null. And it would be similar with some of these other tasks. Now, this one was just to print out the BGP configuration, right? So we're just printing this on the screen for our own purposes. So this is akin to like just normal, output from a debug command that you would see when you run like Ansible Core Engine, directly on your device. So here we can see, the AS number, the router ID, all the things we configured, the neighbor information, and so on and so forth. And then we made some more changes, towards the bottom. Here's some MPLS stuff. Right, so this one I used like the config module because there wasn't a resource module for that, but it didn't warrant like needing a whole template, I believe. I just did like a one-off one for that. So that's just one stage. So to see everything else, we can go back. Oh, and we had a problem here, so let's see what happened. All right, so this is the overall state. So what happened here, normally what this means is that it didn't have enough time, right? So sometimes it needs more time to bring up and converge like from end to end all the way over. So it probably just failed. And let's see how I set this one up. So we waited for a while and see how it says timeout. Yeah, so it failed there. So what I could do, yeah, we want to OK, but we have a timeout condition. So sometimes that happens too because of the CML, right? So I think when I'm logged in this way, I might not be able to just run it directly from here. I might not have access to do it from here like this. Yeah, so this one, what I need to do is I'm going to log in as an admin. I'm going to go back to the jobs, right? So we were here, but this is what failed. So what I want to see, was it just a matter of timing or is something else wrong, right? So I'm going to go ahead and try to run this again from here. And this is going to take a minute too because we got to wait. It has that pause in it. But we'll let this one run and we'll see if it passes or fails. If it passes, it was just like we needed like a few more seconds or something like that, or I needed to give it like another retry. But we'll go back while that runs. What I want to show you real quick, because we need to kind of cut this video off here in a couple of minutes. So go back to the jobs and go here. And then this is the last one that passed, right? So here we were just implementing the configuration for the IP SLA. So that's not too important other than, it's using the VPN 100 information. But if I go, okay, so this time here we ran it and it succeeded. So you can see it's okay now. So it was just a timing thing. So that was my bad. I need to give it like a little bit more padding or do like a different condition before we run it again. But you can see all checks passed. Right, so that's what that was. So we kind of saw the output, right? And we know that we have a working configuration right now that's end-to-end because we can ping from the one side of the distribution to the other across that VPN. So how do we do all that stuff? So in the repository, I just want to take you through the correct repository. We'll just kind of walk through the order of operations. So one of the things is playbooks. So our job templates map to all these playbooks, and then we orchestrated them in a particular order because we have a workflow. But the first one that we ran was the core BGP. But you can see in this playbook, all I'm really doing is I'm pointing to the inventory to the group called core. And if you recall, the core routers were iOS XR routers. The next thing that I'm doing is I'm including a role for the core BGP. So this playbook is doing nothing other than just pointing to the inventory that I want and then calling this particular role. So all of the logic is really in the role itself. So if I go into the roles, and I can go into the core BGP task, iOS XR, then this is what we were actually building. So you can see here, we have some configurations at the top here, like some real basic stuff. So I'm just using the config module. But then as we get into BGP, I'm leveraging the resource modules, right? So this is the one iOS XR _ BGP _ global. And then we can have, different address families, like for IP version 4 and IP version 6, right? So that's a completely different module, right? So that resource module is this one down here, the iOS XR _ BGP _ neighbor _ address _ family, right? So we have some of the configuration here. And then I have a one-off for this piece of the MPLS LDP configuration. So I'm applying it to this interface, right? So I have a parent configuration, and then we're applying this interface. We're applying this interface into this parent configuration. So that's why we have the parent and then the line. Right, so this one's a bit of a combination because I mentioned that some of this stuff is not in the scope of the resource modules. So that was the core BGP stuff. Now, if we go into other roles, you'll start to see some of them had templates. So here's the rollback. Right, so if it fails, this would be the rollback. You didn't see the rollback in our failure because all the configs worked. It was really just that IPSLA at the end. So there was no rollback, implemented anywhere there. But if we had a rollback, then we're removing configuration. So one of the ways that we can remove BGP wholesale from a device is use the state of purged. But purged is going to rip out everything BGP. So you need to be careful in how you use that. Oftentimes, if you're just removing one autonomous system and not all of your BGP, then you wouldn't use purged. You would actually use deleted. So there's various states when you go into the configuration documentation for these resource modules. It'll show you there's a state of merged. There's also a state of replaced, which is really good for compliance checks, because if it compares your config with the existing config, if there's anything in there that exists that's not in your config, it will remove it because it'll assume you want to delete just that one thing, and it'll add only the things that are not already there. There's another one called overridden, and that one's kind of scary because it'll rip out everything first and then apply your configuration. So you might have some disruption because of reconverging whatever that configuration is, depending on how it's set up, it might take a little bit of time and be more disruptive. And then we have delete it to remove a config from a resource module. Purged is when we have like resource modules that are kind of grouped together. It'll like remove all of them that are like inner dependencies between them. And then we have parsed, which allows us to see the command lines. So if we want to see all the command lines that were used on a device, we can use parsed and it'll pull them in. There's gathered that'll pull in the structured data configuration. So that one's good for like building configs that we want to automate. And yeah, so we have all these states available, and each one of them has more explanation when you go into the documentation. Right, so we had that one, and then let me just look at a couple more. So we got into like the distribution VPN stuff. Let's look at that. So here you can see I'm setting facts based off of what we select, right? So if we select, these are conditions here. So my variables are different depending on what we select in that survey. So if we say VPN 100, or if we said VPN 200, then we have different variables that we're going to call. So these variables are populated over here. So I have here the host file, and you can see I have group variables. I'm sorry, I have host variables, right? So this is the core group, and then the host is core-router1 here. These are variables that are specific only to router 1 in the core, and then these are for router 2. And we select different variables depending on which VPN number we're using, right? So that's what I mentioned earlier. There's different IP addressing, and specifics depending on which one we choose. But the local AS is always the same and stuff like that. So we went to the distribution routers, the IOS XE routers that are in the topology, then same thing. We have interfaces for 100 and 200 and different IP addresses depending on what we select. And then some of these variables are just things that are more generic, like group variables, right? So for the iOS and network CLI, those types of things. And we saw this earlier in the GUI because we ingest this information into the GUI. We saw this one here was because I had that pipeline config. So that's where the variables are, and we had some conditions. So a couple of other things. I want to show you this. It's pretty important. This is how we do validation checks. So on one end, or the front end of this, we might use a parser because we're doing like a show command. So if I'm showing the BGP neighbors, what I can do here is create criteria based off of JSON, and I can use that with the validate module. So on the front end, I'm saying, here's the path to the pattern, which happens to be that element or that value in a dictionary, and it has to be established, right? So it's looking for that specific value. If it saw idle, then it would fail. So only if it's established. So the same thing happened with that IPSLA. So if we look at that one, iOS IPSLA, it was looking for the pattern of OK, which would suggest that the IPSLA succeeded for those ping tests, from end to end. But we had some that timed out, right? So that condition created a failure. So this is where we define like the pass criteria that we're looking for. Otherwise, it fails. It's not true. And then the other side of it is like if I go into the playbooks here and I'll look at the IPSLA config, that configs the results. This is what we want to see. You can see here that I'm doing a parsed with a show IPSLA summary command, and I'm using PyATS, right? So it'll register that response. And then what I want to do is I want to print it on the screen so I can see it. But then what I wanted to do was use the validate right here. This is the validate module that's in this utils collection. And what I can do is point in that data, and then we can use the criteria. So lookup will just find that file, but I actually gave it the actual path to where it is. So once it finds that file, it's going to change it from JSON, right? And it's going to, read it in, and then in memory, we'll be able to use it in our playbook. So this is the engine that we're using, JSON schema, but this could also be YAML schema. So this file could be written in YAML too, so it's really just a preference. But what's important here is whether or not it passes or fails. So we want to register the result and then print that on the screen. So that's where we saw that the test either passed or failed. That was actually shown on the screen because of this debug of the result. So that's how that works. So you can do all sorts of pre and post checks, and it's pretty straightforward. You just have to know how to parse data, or where to, how to point to the data that's parsed, right? So to navigate that path through the data that's parsed. And if the data is not already JSON, then you can use a parser. So I had to use, in the utils collection, the CLI underscore parse module allows me to point to a parser. But in reality, like, it's not just the collection. You also have to have PyATS that has all those Genie libraries and stuff, are also a part of your requirements.txt. And that's something we didn't get into, which is like the underneath all of this stuff, there is an execution environment, and you would have to package like all the things that you need, all the requirements. But that's for another day. That's a whole discussion in itself. But we'll cover that. We'll cover that in the study group. So that's pretty much all the main points of how these things work together. I know there was a lot of moving parts there, but I think the important thing is, like, how we can build it in layers and then implement it and manage it, through a workflow. And then we saw in the workflow, whether or not a stage or a playbook passed or failed. And then we were able to go back in and rerun the one that failed, just to validate that it really wasn't a failure. It was more of the way that I implemented it. I didn't give it enough time. And that's because it's kind of hard with these CMLs. It's like virtualized, and it's not like a real data plane. So sometimes it takes like really long for some of these environments to come up and change, to converge on routing and all that kind of stuff. But in an actual real network, it's typically a lot more stable. But this is, just for demonstration purposes. So I'm going to go ahead and come back here and pause for any questions, because that was a lot. And I'm going to cut this recording off here in a minute, depending on what questions we have. Not because of the questions, but like a timing thing. If you ask me something I can't answer, I'll immediately cut off the recording. Okay. Yeah, wait for. Yeah, that's a good one too. I do that for connecting back to a router. You can do the wait for that one. So that one's pretty nice. Like SSH, do that like locally. That's a good one. All right, so I'm going to go ahead and get back to the recording and stop it.